Howdy, I'm Landon Baumgartner, KE8TJU. I'm a general class operator, martial arts champion, and a cadet staff sergeant in Civil Air Patrol, aka CAP. I've been a ham for a year and a half now, and a general for most of my time as a ham. I became a ham shortly after my dad, WV8U, got into the hobby after a 20-plus year absence. Today I will be talking to you about antenna building and why you should build your own antenna. Antenna building is a very tedious, grueling, yet rewarding project. What makes antenna building so hard is that you need antenna to have a low SWR where you're going to use it, but this can be a very long and tiring process. You can have one good day, but the next is hard and frustrating. You can spend weeks and even months tuning antenna, but in the end, you're proud of what you have built. Here's my 5-step guide to building antennas. So you may be wondering why there's a big question mark on my screen. Let me tell you. The first step in building an antenna is answering these questions. What is the antenna for, and what do you want it to do? Once you answer these questions, you can start brainstorming ideas of how you will make the antenna work. Be sure to write down all these ideas so you can remember them. The second step of building an antenna is picking a fun and catchy name like DX Conquistador, so you don't have to call it a boring name like 30-foot fourth wave fan vertical. When I'm thinking of these names, I take the antenna's best quality and convert it into a different language to make it catchy and funny. Up on the screen are some of my favorite places to get antenna supplies, which include Send Cut Send, laser cutting, Jackkite fiberglass poles, and R&L electronics. This leads me into step 4 of building an antenna, getting my supplies so I can start taking the correct dimensions. This picture, I'm measuring the DX Conquistador, my dad and I's version of the DX Commander. The DX Commander is a fourth wave fan vertical that is made and sold commercially by Callum M0MCX. In step 4 of building an antenna is getting the dimensions of the mast and wire to design custom parts if necessary. For example of custom parts we have built in the past, like guy plates and wire organizers. We design these in 3D design softwares, and then we order the parts from Send Cut Send. In this slide, I am testing an antenna in my backyard right after I put it together for the first time. This leads me into step 5 of building an antenna. This step is assembling all the parts and testing it. These steps include cutting the wire to the length it needs to be. For testing the antenna, I use a Nano VNA antenna analyzer, which is a great inexpensive antenna analyzer. Then I figure out how much I need to cut or add to the antenna. For where I want it to be resonant. I do this by using basic antenna length calculations. This is the part I talked about earlier of what makes antenna building so hard. The final step of building antennas is the most fun. It's getting on the air and making contacts, whether it's in a POTA or at home. Here are some antennas I've built in the past. We'll start with the DX Conquistador, a fourth wave fan vertical that me and my dad built off the famous DX Commander. We started by using the DX Commander's instructions with our own parts. We made a few changes along the way, such as lower loss wire, also a green pole to blend into the woods, and a pipe in the bottom to make it more stable. The next antenna I will talk about is the DX Muchacho, which was a scaled-down version of the DX Conquistador with a 20-foot pole instead of a 30. The Muchacho had a 17-meter element, a 20-meter element, and a 40-meter element with a coil to raise the electrical length on 40 meters. About 1,200 airplanes crash every year. Only 1/4 of those crashes are fatal due to a handy tool inside of airplanes called an ELT, or an emergency locator transmitter. When an airplane crash, an ELT goes off, then local ATC towers receive these signals and contact the U.S. Air Force, and they deploy a Civil Air Patrol emergency services team. When CAP gets into the field, they start using a little ELPer, which is a directional antenna. A little ELPer is an urban direction finding unit. Being on a CAP-ES team, me and my dad noticed the problem with the type of antenna CAP used. It could take you 180 degrees in the wrong direction away from the downed aircraft. So when we got home from training, we started to think of ways we could improve the antenna. We ended up looking at another ham who's in CAP solution, which was a tape measure Yagi. He made a couple of improvements to his design, then I built it. We now call it the Aero Chasseur. With this new antenna design, like this one, we can cut average mission times down in half from 10 hours down to 5 hours or less. If we spread this antenna design, we can hopefully reduce 1/4 of plane crashes being fatal down to 1/8, with major improvements coming to ELTs and receiving equipment. Hope we can have one day where 0 plane crashes are fatal. Here's a little show and tell. This is the little helper I talked about earlier. This is the direction finding unit. Here is an helper antenna. This is the antenna that could take you 180 degrees in the wrong direction. I brought a smaller version of the size we'd use for this frequency because I couldn't fit it in my backpack. This is an ELT out of an aircraft. I was lucky to get my hands on it, and this is what happens when a plane crashes. G-forces detect, and this thing starts going off, playing a beeping sound like beep, beep, beep. This is the Aero Chasseur, the improved design, and this makes it so we can cut average mission times down from 10 hours to 5 hours or less by taking us pinpoint in the right direction. This, you point wherever the signal is strongest, that's where it takes you. Finally, thank you to Carol Perry and Radio Club of America, as well as ICOM for this amazing opportunity. This forum would not happen without them. Also, thank you to my mom and dad and the rest of my family. Have a good day, everyone.